This is our lecture number 2 of chapter Gravitation. Today we are going to discuss the other key points: gravitational force, or what is gravitation, and universal law of gravitation, and to calculate the calculation of small g, that is your acceleration due to gravity. So in our previous lecture, lecture number 1, we have already completed the introduction part and bodies in circular path. Okay, means some forces acting like the centripetal forces. Okay, so today we shall discuss about that gravitational force law and calculation of small g. So student, first the definition, that is your gravitation, that the phenomenon of attraction due to masses of body is called the gravitation. So student, to know about what is gravitation, we need to go back in time to the Newton's age, because Newton was the first scientist, physicist, mathematician, philosopher who actually shown the experimental approach to science. He wrote a famous book called Principia. Famous book he wrote. Here in this book he mentioned so many things which we already discussed and going to discuss in the chapter called mechanics, the study about the rest and motion. We have already completed, and your higher classes you have to study the basic things, very practical things about the rest and motion of a particle, that is the mechanics discussed in this book. And this is also a part of discuss in mechanics from this book. That part is the gravitation. Okay, so Newton is famous for two things. One is laws of motion, and second is law of gravitation. Newton is famous. Okay, and he explained that the gravitational force between two massive bodies. And he explained that the gravitational force between two massive bodies means, what is massive bodies? Means which have masses. Okay, is attractive. Suppose this is a mass, that is m1, and this is a mass m2. Okay, here there is two masses having masses, two massive bodies. That means which have masses is attractive. The gravitational force is always attractive. Between two massive bodies, means see the diagram. This is mass m1, this is mass 2m, m2. The distance between mass m1 and mass m2, the distance we should suppose r. Okay, the gravitational force is always attractive between two massive bodies. Means see the m1 and m2, two point masses, but it is not always correct. Sometimes you can take big masses like this, like sphere, like that, like spheres, big masses. Still the diagram is correct, because what Sir Isaac Newton mentioned, that how big the body you take, but the total mass always concentrate at a point in the body, and the point is called the center of mass. Here that is this diagram. See the diagrams. There m1 and m2 are two massive bodies, and the total mass always concentrate at a point, and that point is called the center of mass. So what type of body you take, what shape of body you take, or how much weight body you take, the whole mass is concentrated at a point. That point is called the center of mass. Or from the center of mass of the body to the center of mass to the other body, here considering. Okay, so Here M1 and M2 are two massive bodies we can consider. At that point is called the center of mass. The point is always concentrated at a point in the body. So point masses M1 and M2, point masses M1 and M2, there is a separation between two masses. The separation between two masses is, or the distance between two masses is r, where the r is the distance between two massive bodies, 2 points. Okay. Or Sir Isaac Newton mentioned that here the force is acting between them. The force is acting between them. Actually, it's law. Actually, this gravitation means the phenomenon of attraction due to two massive body. देखो हमारा जो means वर्ल्ड है, दोनों masses में attraction है, always attracting between two particles, two bodies. ठीक है? तो जो फोर्स लगेगा अट्रैक्शन की उसको क्या बोलते हैं? मींस जो फेनोमेनन को क्या बोलते हैं? ग्रेविटेशन. और जो फोर्स लगेगा that force is called the gravitational force. So here F is the force of gravitation. Force of gravitation means gravitational force. Here the law, universal law of gravitation says that Sir Isaac Newton mentioned that the force is directly proportional to the product of two masses, means directly proportional M1 M2. Here the law says that the force between two, or the force is acting between them, or the force is force of gravitation or gravitational force, or force is directly proportional to the product of two masses, that masses M1 M2, and inversely proportional, the force of gravitation is inversely proportional to the square of distance between them, the square of distance between them. Okay, and this is also called as inverse square law. What? Inverse square law. What? Inverse square law. The law, universal law of gravitation states that the force is directly proportional to the product of two masses and inversely proportional the square of distance between them, and it is inverse square law. It is also called as inverse square law. So the question is, what does it mean? The inverse square law. What is the proper meaning? What it means? Sir Isaac Newton was expressing that if the masses increases in their magnitude, then the force also increases. If the masses are increases in their magnitude, then the force also increases. Okay, that is called the directly proportional. Means यहाँ पे mass increase होगा तो force sure increase होगा. That is the directional proportional का that physical significance. And inversely proportional 1 by r square means where the distance means what? Where the distance means what? The distance between two masses. If masses are increases, then force is increases. Here masses are decreases, then force also decreases. So that is called the directly proportional. Inversely proportional means, suppose the distance between two masses, that is r, is increases. Then force decreases. And the r is decreases, then force increases. That is the inversely proportional. That is called the inverse square law. Okay. Here the combining two factors. We get F is proportional to M1 M2 by r square. And 2 remove the proportionality constant, we keep a constant, you keep a proportionality constant, that proportionality constant is capital G. According to mathematics, you know very well. So ये proportional को हटाएंगे हम, तो proportional हटाने के बाद क्या लिखेंगे? Proportional constant लिखेंगे, where capital G the proportional constant square, और G is called as gravitational constant. What? Gravitational constant, also called as universal gravitational constant. What? Universal gravitational constant, and its value is 6.67 into 10 to power minus 11. So what is the unit? Where unit? Here you can see that capital G equal to F into R square by M1 M2. Okay, here you can find out the unit. F, that is your Newton, resistance meter square, then kg square. So unit is the Newton meter square or kg square. This is your SI unit. This is your SI unit, and you can write in terms of CGS unit. That is your dyne. Newton का CGS unit क्या है? Dyne, centimeter square or gram rock square. This is your CGS system. And dimensional formula, you can find out the dimensional formula. Here force mnt minus 2 and distance m square and m1 m2 m square. Sorry, distance l square. L square here m square mass. Here 1 2 ऊपर चले जाएगा तो m minus 1 L1 plus 2 3 T minus 2. That is your dimensional formula of universal gravitational constant. Its value is always fixed, always constant in our universe. That's why also called as universal gravitational constant. So here the question is, what is gravitational constant and where its value is always fixed, always constant? That value number, it is the number. Constant means number 6.67 into 10 to the power minus 11. Or if you put, if m1 equal to m2 equal to 1 kg and r equal to 1 meter, then here you can put that f equal to 1 into 1 and 1, f equal to g. Means the universal gravitational may be defined as the force of gravitation. The force of gravitation is equal to universal gravitational constant. So question is, what is universal gravitational constant or why its value is always constant in our universe? That's why it is called the universal gravitational constant. Wherever you go in the universe, you can apply this formula. This formula that F equal to G m1 m2 by r square. Okay. So students, actually wherever you go in the universe, you can apply this formula. So that the interesting thing about this formula, as it is applicable universally, that this formula also called as universal law of gravitation. What? Universal law of gravitation. Universal law of gravitation, also called as universal law of gravitation. So here the concept: R is increases, force decreases. R is decreases, force increases. That is universal square law. Here mass is increases, force decreases. Mass is decreases, force increases. That is the basic concept. Usually that formula also called as universal law of gravitation. Now the questions: how Sir Isaac Newton has got the number 6.67 into 10 to the power minus 11 Newton meter square kg square? How the Sir Isaac Newton has got the number? no one knows. In old historically books also, it was mentioned that Sir Isaac Newton wrote this number like that. There is no experiment, there is no mathematical proof, but how did know this number is correct? How can we agree? There was no mathematical proof. Later in modern century, the scientist was did experiment to check whether the value right or wrong. And most surprising is that experimentally it is correct. So that's why Sir Isaac Newton was very famous and called the father of classical physics, modern physics, father of modern physics or classical physics. Now come to the concept F equal to G m1 m2 by r square. Apply the formula specially for the earth. And mass on the surface of the earth. Mass on the surface of the earth, especially for the earth. Suppose here the earth, the mass of earth is m. The mass of earth is m. Mass of earth is m. Mass of earth is m. And mass on the surface of the earth, small m. Mass on the surface of the earth, that is small m. So here we can find out this capital M mass of the earth, small mass on surface of the earth, and the distance between the earth and the mass, capital M, that is called radius of earth and r, capital R. Same formula, this formula also applies. The formula is applicable for this case also, which is the radius of earth, capital R, and capital M mass of the earth, the distance between the center of the earth and mass, small m. Now what is the formula for the force of gravitation? Same formula we will apply, that is F equal to capital G. Here the mass of the earth, first m1, here m1 is the capital M, m2 is the small m, and distance, that is the radius of earth, also applicable. So this is the formula for this concept, especially for the earth. Okay, here you can find out capital G, that is G F R square m m. Okay, so this is the formula for the concept. So this case, especially for the earth, that also formula will be applicable. Okay, so first of all, we should know what is the formula for the force of gravitation. Remember in your mind, store in your mind, that is F G m1 m2 by r square. Here you can find out the distance between two mass. यहाँ से हम डिस्टेंस भी हम फाइंड आउट कर सकते हैं, तो ये फॉर्मूला को याद रखो फर्स्ट, ठीक है? तो these are the universal law of gravitation, and the law states that Sir Isaac Newton mentioned in this law, the force acting between them, or force acting between two massive bodies, is directly proportional to the product of two masses. क्वेश्चंस आएगा स्टेटमेंट, उसका मैथमेटिकल डेरिवेशंस आएगा. Force is directly proportional to the product of two masses, inversely proportional 1 by r square. Combining two factors, we can find out this formula. So these are the mathematical derivations and what? The universal law of gravitation. Understood? So important characteristics are, first one is gravitational force between two bodies form an action and reaction pair. form an action and reaction pair. That is, forces are equal in magnitude. So here the mass, the force is acting. Force from 1 to 2 means force on 1 due to 2, F1, and here F2. Equal magnitude but opposite in direction. That is forms action and reaction pair. You know Newton's third law. Every action there is an equal and opposite reactions. Okay, that's important characteristics, part characteristics. Number 2, the gravitational force is a centripetal force. ये क्या होगा? First, action and reaction pair. Action and reaction pair. ठीक है? Number 2, it is a central force. Central force में क्या होगा? ये जो लाइन है वो सेंटर से लाइन जर्नी होगा, दोनों मास का जो डिस्टेंस है, that's why it is a central force. Line joining between the two masses, or it acts on the line joining the center of two interacting bodies. Okay, so it is a central force. Or third bit, I will provide its concept notes. Don't worry that. Make down or make a rough notes. Okay. So number 3, the gravitational force between two bodies is independent of the nature of the intervening medium. Means दोनों में जो masses में है उन दोनों का जो force of attraction है, वहां पे जो भी एक obstacle आएगा, any other medium आएगा, जो भी वहां पे कुछ फर्क नहीं पड़ेगा. तो ग्रेविटेशनल फोर्स ये है. कोई भी एक बीच में कोई भी ऑब्स्टेकल्स आएगा तो वहां पे कुछ एनी थर्ड मीडियम आएगा तो कुछ भी फर्क नहीं पड़ेगा. बट हाईएस्ट स्टडी यू कैन गो थ्रू द हाईएस्ट स्टडी इन +2 और 10th क्लास. आप लोग पढ़ेंगे आप इलेक्ट्रोस्टैटिक फोर्स बोल के, दोनों चार्ज के बीच में एक मीडियम आएगा तो वहां पे इलेक्ट्रिक फोर्स चेंज होगा. आप लोग हाईएस्ट स्टडी में पढ़ेंगे. बट इन दिस ग्रेविटेशनल फोर्स देयर इज नो any third medium or independent of the nature of the intervening medium. Or what are the importance? This is the important characteristics. But what are the importance of universal law of gravitation? Now the force that binds us to the earth first. The force that binds us to the earth. And the motion of the second one, the motion of the moon around the sun. Third one, the motion of planets around the sun. And third one, the tides due to the moon and the sun. Okay, so these are the importance. And last one is to calculate the small g. To calculate the small g. देखो, to calculate the small g. To calculate small g. Small g means क्या है? That acceleration due to gravity. Acceleration due to gravity. In your NCERT book, that is mentioned free fall. Free fall किसको बोलेंगे हम? Suppose take a stone. Take a stone. Stone को ले जाओ. ठीक है? उसको हम suppose upward direction में, क्या upward direction में हम उसको हम फेंकेंगे. Means क्या upward direction में जा रहा है? कुछ certain height जा रहा है, फिर falls on the ground. Means upward direction and downward direction. What? Upward direction and downward direction. तो stone का example, suppose thrown it upwards and it reaches a certain height, then it starts falling down. That is called the free fall. Okay. तो acceleration due to gravity जो small g है, you know that from the Newton's second law of motion, F equal to ma. Or here that acceleration we can replace acceleration due to gravity, that is F equal to m into g. Okay, so we know that small g value, that is your 9.8 meter per second square or 10 meter per second square. तो देखो here F equal to g mm by r square, where you can find out the, or you can put out the formula of F, that is mg, and capital G mm by r square. Small m cancel, g capital G m by r square. and here find out all the values. Put out all the values. That G 6.67 into 10 to the power minus 11. Or here capital M mass of the R. Capital M is the mass of the R. Or its value is 6 into 10 to the power 24 kg. 6 into 10 to the power 24 kg by radius of Earth. We know what is the value of radius of Earth. 6.4 into 10 to the power 6 meter per second square. 6 meter per second square. Here kg, here that is Newton meter square or kg square, or we can calculate. Okay, खुद calculate करो. इतना calculate करने के बाद we can find out the number 9.8. Acceleration means unit is meter per second square, or we can consider 10 meter per second square approximately. So that is the relation between small g and capital G. Small g and capital G called free fall. And we know that from the motion under gravity, we already completed the chapter laws of motion, motion in one dimension. Okay, in our previous chapter motion and laws of motion, we know that motion under gravity, the equation of motion in upward direction, we can take A equal to minus G, and equation of motion V equal to U minus GT, to that is your S, H represent करते हैं हम लोग, H equal to UT minus half GT square, then V square minus E square equal to minus 2 GH, and downward direction you can consider A equal to plus G, that is V equal to U plus GT, number 2 H equal to UT plus half GT square, and number 3 E square minus E square equal to 2 GH. This is the equation of motion for motion under gravity. So that is all about the free fall, and the value of small g we can calculate, and we can find out the value of small g, that is 9.8 meter per second square or 10 meter per second square. So this is all about the gravitational force, important characteristics, universal law of gravitation and importance, and to find out the small g. Okay, so next class we are going to solve some standard numericals about this formula and this formula. Okay, gravitational force, then small g. Okay, इंटेंस क्वेश्चन करो, ठीक है. नेक्स्ट क्लास में हम न्यूमेरिकल सॉल्व करेंगे. इंटेंस क्वेश्चन इतना तो 3-4 क्वेश्चन से वो रिलेटेड है. ओके, आई होप यू ऑल आर अंडरस्टूड. ओके, तो सी यू इन द नेक्स्ट क्लास. थैंक यू.